outcomes for today are to describe how the graph of a function can be obtained through transformations, and then writing some equations and graphing those transformations. First off, let's take a look at what we mean by a transformation. A transformation is basically taking a graph of a function or a relation and changing it. So, for example, I could have a translation where I'm moving off to the left, or a transformation where I'm moving off to the left. Some people call it a translation. Or I could have it going to the right, up, or I could have it down. I could take it and I could actually flip it over. Whoops, that's not flipping it. Here's a flip over. So I could flip the graph over. So any of those kind of things are called transformations. And so what we'll do today is just explore 4 different types of transformations. Now the interesting thing about all these transformations is that they're very similar, almost identical, for many different kinds of functions. Here's a list of a bunch of different functions that you've probably seen already or will see in this class. So we have a quadratic function, a linear function. This looks like a square root, absolute value, sinusoidal, logarithmic function, and an inverse function. So each of these, if I wanted to transform them, I could do that. I could take and move the graph left or right, up or down. I could flip it over, make it skinnier, make it wider, etc. So I can do that with each one of those particular functions. Now when I look at the equation of each of these, I start to see some similarities. For example, here's the quadratic function, a cubic, a square root, and an absolute value function. If I take each of these and add 3 to the end of it, I get, when I look at the graph, something that's very common. And so rather than talking about each function individually, we'll talk about them generally. To take any function, when I add 3 to the end of it, it does something to all of the graphs. So I'm not looking at specifically each one of these, although we'll look at an example of them. But you need to remember that the concept that we're applying here applies to all of them. Similarly, if I put a negative sign in front of each one of these functions, something similar happens to each function. And so rather than looking at specifics, I look at generalities. So here is a way that I can describe or write down the 4 different transformations that we're going to look at today. So I can throw a letter out front. I can put a letter in front of the x, inside of these brackets in front of the x. I can put a letter inside the brackets, but instead of being multiplied by the x, I'm adding or subtracting it. And finally, I can put one outside. So those are the 4 different transformations that we could do. Just maybe to give you an idea of how you can look at each of them when you look at the equation or a graph. I typically use the rules of Bedmas to look at them, because sometimes with some transformations, order is important. And so I look at what's inside of brackets. When I see things inside of brackets, I see multiplication, and then I see addition. So this would be, if I'm looking at transformations, the first thing that I would look at. Then I would proceed to this one. This would be the second transformation that I would look at. Then I have this expression here being multiplied by something. This would be the third transformation I would look at. And finally, this would be the last one that I would look at. The other thing that has helped me in looking at transformations is to group these. And there's 2 of these transformations that adjust the x value of my function, and 2 of the transformations adjust the y value. These 2 here inside the brackets adjust my x coordinate, and these ones on the outside, this one and this one, these ones adjust the y coordinate of any point in my function. And we'll look at each of those later. Now, a tool that I found real handy when I'm looking at transformations Graphing calculators are great, and this one here I've found very superior. It's called WinPlot. If you do a Google search for WinPlot download, you'll find it. You can download, install it on any Windows-based computer, and it seems to work really well. And I've just queued up a few functions or transformations of the absolute value function. So initially, here is just my normal absolute value function. Nothing fancy, it just sort of looks like a V. A couple characteristics is its vertex or point of reflection here is right at the origin. So that is my absolute value function. Now if I take and I do something in front of that absolute value function, let's see what that does to the graph. Just watch the graph. I'm putting a 2 in front. When I display the graph, take a look at it. So this one we had indicated was a y value, or it would change y values. Let's take a look. So if I say have an x value of 1, it looks like by putting a 2 out front there, instead of my y value being about 1, it looks like it got doubled to 2. Let's check out here. My x value is 2 and my y value was about 2. When I doubled it, when I put a 2 in front, it looks like the y coordinate jumped up to about 4. So it appears as though by putting the 2 here, I keep my x values the same, but I double my y value. We'll see how that works in an equation in a minute. Let's try a different one. Instead of putting a 2 in front, like I did here, let's put a 0.5. Let's graph this one. As I sort of thought, it went wider. So I take all of my y values and cut them in half. So here I had an x value of 1. The y value originally was 1. But when I applied this, the 0.5 in front, or my a transformation factor, it cut that in half. So at 2, I used to be up at 2, now I'm only at 1. So the y values, this number out front, the a idea, has a bearing on the y value. Let's hide that. Let's look at another one. Here we've got the absolute value function, and at the end I have subtract 2. So let's see what that does. Let's see what that does to my graph. Oh, it looks like it just took the whole graph and moved it down by 2. And I'm sure that if I put a plus 2 there, the whole graph would move up by 2. You can try that. But again, my y values, my x values, it didn't move left or right. The graph didn't move left or right, but my y values moved. So this time, instead of multiplying my y value by a certain number, I'm either adding or subtracting my y value by whatever this number is. Okay, so that sort of takes care of the y values, and specifically in that long function that I had listed, it was the a and the d values. Let's look at the b and c, the ones in between the brackets, and I probably should have started with those. Here's one here. I put in a number in front of the x. Let's see what happens there. And I said that we had to do something with our x values. Okay, so we'll sort of set our y value and see what happens with x. Let's graph that. Oh, that one looks a whole lot like this one did up here. But let's explore it here. So say if I had an x value or a y value, right? We're supposed to look at y values. Say I had a y value at 1, x was 1 before. So here, if I have a y value of 1, it looks like my x value got cut in half. Let's test it with another one. So let's go a y value of 2. In my original graph, it looks like I had about 2. But in this new graph, it looks like the x value is about half of what it was originally. So it appears as though this 2, rather than multiplying the x values by 2, I divide the x values by 2. That'd be a good idea to play with that a little bit in WinPlot, and just play with that number. Maybe throw a negative in, see what that does. Okay, finally let's look at what happens when I take the x value inside the brackets and add or subtract something. You're probably on to the game now and you're probably thinking, well, this probably moves it left or right. Well, which way is it? Did you guess? Okay, I'm betting left. I should have bet beforehand. Sure, so if I have a plus 3 in here, you sort of think that it should go right, but when you look at the equation on the other page, there's actually a subtract here. And so it was x subtract whatever the value was. If I have an x plus 3, and we'll look at it in an equation, it's actually x subtract a negative 3. So it does make sense for the graph to move left. Typically students will just memorize that the one inside the brackets there, if it says x plus 3, it goes opposite to what you'd think. But there are some equations that we can see that confirm that. So WinPlot's a real powerful tool for looking at these transformations, and you need to be able to look at any of the transformations, whether there's a number out front or inside the brackets or outside of the brackets being added or subtracted to, and be able to determine what that graph does. Now, just as a sort of final example for this section, here's a graph, and notice that it's sort of a combination of a few graphs, but it's just any graph, and it's not really a quadratic or absolute value function, although there's pieces of both of those in there. But what I want to do is take a look at this graph here, and I want to apply some transformations to it. So this is my graph, y equals f of x, and what I want to do is apply some transformations. So I'm going to be putting a number out front, and it looks like, oh, there's no b there. The letter or the number in front of x is just a 1, therefore there's no transformation there. That's good. Plus 2 minus 1. So I want to take this graph, whatever that is, and apply these 3 transformations to it over here. Okay, when I'm doing a graph like this, I always like to hit on critical values. Typically critical values are where the graph changes direction or where it crosses an axis. So I'm going to look at this critical value, this one up here, this one, and this one. So we'll just look at 4 values, and then we'll apply the transformations to each one of those. And finally we'll put the graph over here. So let's look at our transformations. We said we should start in brackets, and inside brackets here there's nothing in front of the x, so I don't have to worry about that transformation. But I do have a plus 2. We just saw that if I have a plus 2 here, the graph moves to the left, remember, 2 places. And so I would take each of these critical values and move them 2 places to the left. Let's just do that. 1, 2, so here would be a new point that I would have. And here I'd have to move 2 to the left, right about there would be a point. This one 2 to the left, right about here would be that point. And this one 2 places to the left, right about there. I don't have a scale, but I'm just ballparking. So if I take a look, I could draw, you know, the sort of intermediary function already. But that's only one of the transformations. That's only the plus 2. Now, which is the one that I'm supposed to go to next? Is it the minus 2 or is it the minus 1? If you said the minus 2, that's correct. Remember the bedmas, this is multiply, so I'm going to do this one first. So I need to, we said, take all of the y values and multiply them by whatever this number is out front. So let's do that for each of our critical values. So here's a critical value. The y, I don't know what the x value is, but I do know the y value is 0. Don't know what the x value would be, but if I'm supposed to take this y value and multiply it by minus 2, I'm still going to get 0. So this critical value will stay. Also this one and this one will stay because the y values for each of these coordinates are also 0. I'll just put that in. But this one up here, I'm not sure what the y value is. Why don't we call it maybe 3? let's say it's about 3. On a question in an assignment, they would give you the values. But so say that this, I don't know what the x value is, and that I'm not too concerned with that. But the y value, let's pretend, is 3. And so this number out front says multiply the y value by this. So here, if I've got a 3 and I multiply it by a -2, the y value comes out to be a -6, which is actually way down here. Again, I'm keeping it straight so the x's are the same, but the y value there would be a -6. So sort of my intermediary kind of graph would look something like this. It would go down to this point, it would go up to this point, and then I don't really have a point on this one that I could have looked at, but if this side got flipped over like that, I would assume this side would get flipped over too. And I could get an intermediary or a critical value here or here, and I've proved that. Okay, so notice I got this one about twice as high as I got this one. It got flipped over and it's twice as high because of this -2. The final one, the final transformation to look at, is the -1, and we saw that that was just a vertical translation, or moving things up or down. And the -1 would indicate that I move down 1. So I take each of the critical values and move them down 1. There's down 1, down 1, down 1, this one down 1. I could have had a critical value here somewhere. I could have put it down 1. And now I just join up the dots. Let's do that in red. I haven't used red yet. So there to there, and then my nice little curvy thing to there. So there's my transformation of y equals f of x to y is equal to -2, f of x plus 2, take away 1. We looked at 3 different transformations in this order. This one was first, then this one, and then the last one. We'll be doing transformations in lots of the different sections this year. So exponents and logs, trigonometry, polynomials. We'll be looking at transformations of each of those. And so it's important that you get that idea of what those transformations do. Okay, thanks. Talk to you later.